Good evening, all of you. Today's session, we are going to see about data structures and algorithms. We are going to start full and full this session. We can see the topics and the related questions answers also. Okay, now let me start. First one, syllabus analysis. So what are the syllabus? So that we have to know first. So here, first one in data structures, array and their applications, and sparse matrix, stack queues, priority queues, and linked list. These are the every concept we will get important questions. Each and every questions. So we have to work out every questions we have to solve. Next one, time and space complexity. It's very much important. Asymptotic notation, recurrence relation. It's the last to 1 month before we got question answers. This is from full and full recurrence relation only. And design techniques, divide and conquer, dynamic programming, greedy algorithms, and backtracking, branch and bound. But here it's not so much of important, but we have to see this one. After that, in MCQ questions, which one is important? Breadth first search and depth first search, shortest path, and maximum and minimum to spanning trees are. And P and NP pro class problems and NP complete and reducibility. This is also very much important. Okay, these are the topics we are going to cover one by one, and we will see related questions answers also. Okay, now we can start this one concept. First one, sparse matrix and its representation. A matrix is a two-dimensional data object made of m row and n columns, therefore having total m into n values. Most of the elements of the matrix have zero value. So whenever we are getting the zero value, it's called as a sparse matrix. Actually, this type, or how here, why we are using sparse matrix instead of simple matrix, that we can see. Main purpose, storage. There are lesser non-zero elements than zeros, and this lesser memory can be used to store only those elements. So here it will take only non-zero elements, not zero element, for storage purpose. And maximum it has only zero value. And computing time, it will take computing time can be saved by logically designing a data structure traversing only non-zero elements. For example, you can see this diagram here, non-zero elements. Here I have only 3, 4, 5, 7, 2, 6. That's all. So for this only, it will take storage as well as a computing time. Okay. Now, how we are going to access, how we are going to process this one? We will see. First one, representing a sparse matrix, a 2D array leads to wastage of lots of memory as zeros in the matrix, or no use of most in the cases. So instead of storing zeros with the non-zero elements, we only store non-zero elements. This means storing non-zero elements with triples, row columns value. Here, in sparse matrix representation can be done in many two ways actually. Main common representation. First one, array representation and linked list representation. First one, using arrays. How we are going to represent using array? First one, 2D array is used to represent a sparse matrix in which there are 3 rows named as row, column, and value. Row means index of row where non-zero element is located. Column means index of column where non-zero element is located. Value means the same thing, value only it will take. Now we can see, so this is called as this array, this matrix. Now we are going to represent this array. Row, column, and value it has to write. Now this is 0, 0, 1, 2, 3. So here 0, 1, 2, 3, 4. So here 0 row and second column 3 value. So 0 row, second column 3 value. Now where it is value here? So 0 row, fourth column and 4 value. So 0 row, fourth column and 4 value. Now first row, I have second column 5 value. So first row, second column 5 value. And I have 7. So first row, third column and 7 value. Yes, like this we have to represent in array. So next one, how we are going to represent in linked list. So method 2 using linked list. In linked list, each node has 4 fields. These 4 fields are defined as row, column, value, and next node. Row means index of row, non-zero elements. The same thing, index of column. The next node means we are going to point out the next node for linked list. Here, the same thing, this is a matrix. So how we are going to represent? First 0, 1, 2, 3. So here 0, 1, 2, 3, 4. Yes. So in 0 row, first, second column, I have third value. So 0 row, I have second column, third value, and this one, it will point to the next node. So like this, we have to represent. So this is called sparse matrix and this one representation. Okay, now next to one, today we are going to see the stack, the simple stack, and just 3 questions. After that, we are going to see next video for infix, what is the infix, postfix, prefix, and how we are going to convert. That is also very much important. And that part, we are going to see the question also. First one, stack. Stack is an abstract data type commonly used in most programming languages. This is actually what is last in first out method. That method name is important. So what are the basic operations of stacks? Stack operation may involve initializing the stack, using it, and de-initializing it. Apart from this, basic steps and stacks is used to following 2 primary operation, push and pop. Push means pushing or storing the element onto the stack, and pop means removing, accessing an element from the stack. So how we are going to we are going to insert this value from here. For example, A, suppose I'm going to insert this one, B, push, I'm going to insert this value. Pop means it will take, it's a top of the pointer has to take this pop, this one. Okay, so push operation, while doing the push operation, we have to check whether the stack is full or not. Full means it will come overflow concept. Error will come depends on because of the overflow. So while push operation, this condition has to check. So the process of putting a new data elements onto a stack known as push operation. So these are the steps it has to follow. So check if the stack is full, and if the stack is full produces an error and exists. Otherwise, if stack is not full, the increment stop to point to the next empty space. So it will move on to the top of the next point, that's all. And it will insert. Okay, so next one, pop operation. So pop, while doing the pop operation, it has to check whether it's underflow, because the stack is empty means automatically we can't delete we can't delete. So automatically we have to check whether it's empty or not. If it is empty, no need to do any process, it will produce an error. Otherwise, it will do pop element. Okay, so these are the conditions I have given here. Now we can see this using stack, how they are asking the previous year questions. So infix and prefix and postfix, we didn't see actually stack method only this one. Next is video, we are going to see full what's the algorithm to infix to postfix everything. Okay, here we are not going to so much of calculation, just the stack operations we are going to do. Now consider the following postfix expression with single. Postfix always it will do stack method. Single digit operand, here they have given value. The top 2 elements of the stack after the second star is evaluated or. So here we have to check whether second star, up to second star we have to calculate. So no need to calculate after this one. That is important. That we have to understand while seeing the question. Yes, now we can put in stack just one. First, I'm going to operate operands, everything we have to push, and operators we have to calculate. Now 6 I'm going to push. Next one, say 2 I'm going to push. Next 3 I'm going to push. Yes, next one I'm going to calculate star operation. So this are top 2 operands we have to take. Yes, 6 and 3 into 2, 6. I got. Next one, divide operation I'm going to do. 6 divided by this one. So value will be 1. Okay, so next value, what is the value? 4. Next one I'm going to insert, what is the value? 2. So 2 I'm going to insert. So next to one, I'm going to do the calculation second star. This is one automatically. This two have to take an calculator. So 4 into 2, 8. So up to this one, we have to stop because they have given question like this. So my value will be 8 comma 1. That's all. This is my answer. Okay. Next to one. Now you can see the 7 elements A, B, C, D, E, F, and G are pushed onto the stack in reverse order, that is starting from G. So what we have to do first, we have to start this push operation for where we have to start G. So reverse order F. So next to one E, next to one D, next to one C, next to one B. Yes, next to one A. That I have pushed first this one, this over, up to this one over. The stack is popped 5 times and each element is inserted into the queue. So queue will be there here. So I'm going to insert I'm going to pop one value, I'm going to insert here. So what will happen? A, it will go on into insert, and next to one B. Yes, next to one C, next to one D, next to one E. So I'm going to take first A. I'm going to insert this one. It will go move here. Next to one B. Next to one C. Next to one D. I'm going to move here. Next to one E. I'm going to move here. Just I'm going to take as a Q. So that's Q just I've inserted. Now two elements are deleted from the queue and pushed back onto the stack. Now stack, what is the value? Just again, you can take now what are the values available? Here G and F only available in the stack. That's all. Okay. Now what is the value? Two elements are deleted from the queue. So here first in first out. Queue model is a first in first out. So first which entered, that it has to come out first. Yes. So first it has to A, it will come out, and A it has to push here. Next B it will come out. So B it has to push here. So I have done. So two elements are deleted from the queue. I have deleted and pushed back into the stack. So just push into the stack. That's over. Now one element is popped from the stack. So I'm going to take one element popped. So the popped item is what is the value? So popped item where it has to pop is the last element only from the stack. So last in first out. So B I'm going to take. So B is the answer. Okay. There's also some previous questions. Okay. Next one we are going to see. Now the value of postfix expression. So what is the value of the same thing we have seen as before that? The same question, but they have told us to close in the middle second star. But here we have to calculate everything. They didn't give any restriction. Now we can put as a stack. First one, I'm going to insert the 8. Next, I'm going to insert the 3 value. Next, I'm going to insert the 4 value. Next, what I'm going to do? So just last two values I have to work out. Yes. Plus this 4 plus 3, 7. Next one, last two values I'm going to work out. This is a 1. Okay, next I'm going to insert the value 3. Next one, 8. Next one, 2. Okay, so next one, this up to this one over. This over this one. Now we have to do the division. So what happens here? 1 will come, 3 will come. So division, what will happen? This is 4 it was to come. Okay. So next one, plus operator. So last two values has to take the plus operator. So last two values is a 4 plus 3 is 7. That's also over. Now star we have to do. So star means the last two values. What is the value? 1 into 7. This is 7. That's all. Now just again you can push the value 7. 7 here. Here 2 is there. Now we have to work out. This is power. So this is power means 7 power 2 is a 49. So 49 I'm going to do. Okay. Next we have to push the value 3. Next we have to do addition. This is 49 plus 3. This is 52. So this is my answer after the full and full calculation. So the 52 is my answer. Yes. Friends, I hope it is clear. Next video, we will see about just a continuation we are going to do. Next one, just infix to infix, what is a postfix and prefix, and how to calculate and how to do conversion, and what are the questions available in previous year questions also. Thank you all.